Okay, number systems and relationships. We're going to look at the relationships between different systems of numbers that we've learned already. Now before we go any further, this symbol here has a special meaning. It's like a flat elongated C. We're going to learn a bit more about symbols like this coming up, but for now it means is a proper subset of. Now a proper subset fits inside a larger set, but it will never be the same size as the larger set. If it can be the same size as the larger set, it's just a regular subset. Proper subset is smaller and never reaches the size of the larger set it sits inside of. Now if we reflect on some of our earlier videos, we can see in the graphic here that we have the number sets we've looked at already, the major ones. We've got natural numbers, integers, rational numbers, real numbers, and complex numbers. And we know that complex numbers contain the operator I, which is what forms what's called the imaginary numbers. Now this might seem a bit weird at this stage. We've got real and imaginary, and it's sounding a little bit strange perhaps, but bear with me. We can evaluate the relationships in one certain way when we look at the smaller set here, which is natural numbers, so boldface N, which we learned in a previous video, and that is a proper subset of Z, the integers. If you remember back to a previous video when we were looking at natural numbers and integers in the overview, we saw that natural numbers, whether you want to include 0 or not, 0, 1, 2, 3, 4, 5, etc. up to infinity, and integers included that, but they also had, if you didn't already have 0, they included 0 and the negative whole numbers as well too. So we can therefore say that the set of natural numbers is a proper subset of the set of integers, which in turn is a proper subset of rational numbers. Because remember, rational numbers needed integer over integer. So we can see that yes, all integers, remember, can be expressed as that itself over 1, hence rational numbers. And that in turn is a proper subset, so rational numbers are a proper subset of the set of real numbers, boldface R, which in turn is a proper subset of the set of complex numbers, boldface C. So that plus the graphic above are ways we can analyze the relationships between these number sets. If we look at other sets of interest here, they may include things like Z plus and Z minus with superscripts on them. So Z plus, the plus refers to positive, so that would be positive integers. You can see the benefits in when you're writing this of just using a symbol. This is one of the reasons why we have the symbols. And the negative integers. We can see that sometimes with real numbers too. R plus, R minus. If we looked at one called the non-negative integers, we would look at the integers that are not in the red zone on this number line here. So that would actually include 0, because 0 is neither in the blue nor the red, but the point is it's not in the red, so it's a non-negative integer. And that will include all of these values through here and so on. Okay, there's no limit. Okay, likewise you could have non-positive integers as well if you wanted. Some might say the non-negative integers are the same as the natural numbers if you assume 0 is part of the set of natural numbers. And that's that.